This is an AQA GCSE chemistry question. It's from the Trilogy 19 paper and it is Foundation. We're going to be looking at reversible reactions and the Earth's atmosphere. Going to recommend you pause as you go and then review later. So here is part A, part B, part C, parts D and E, and finally part F. A total of 10 marks available. So now let's go back and take a look. We have got questions about gases and we are identifying what type of substance each of them are. So air, we're going through all of these. Air is a mixture. It contains both compounds and elements. It contains atoms and molecules, but they are all mixed together. Carbon dioxide, water vapour, argon, nitrogen, oxygen, mixed together but not chemically combined. Carbon dioxide is a compound. Every carbon dioxide contains one carbon and two oxygen atoms in a fixed ratio. And finally, oxygen is an element because although it exists diatomically, it exists as O2, it still only contains one type of atom. Moving on to part B, draw one line from each substance to the description of the substance used to test. So carbon dioxide, we will bubble through lime water, and if carbon dioxide is present, it will go cloudy. Oxygen, we insert a glowing splint and the splint will relight. Litmus paper is used to determine whether something's acidic or alkali, and a lighted splint is used in the test for hydrogen. On to part C, give two reasons why the percentage of carbon dioxide in the air has decreased. There's actually two words here that are really important. The first is about the two boxes, and the second is about the fact that we're talking about decreasing carbon dioxide in the atmosphere over those billions of years. A lot of the carbon dioxide dissolved in the oceans. And also photosynthesis, as plants evolved and developed, took CO2 from the atmosphere and put more oxygen in. All of the other three led to increases in carbon dioxide. On to part D, oxygen reacts with sulfur dioxide. The reaction is reversible. We need to know what the symbol is for a reversible reaction. And it's the double arrowhead or double half arrowheads. Half an arrowhead going forward, half an arrowhead going backwards. In a reversible reaction, the forward reaction is exothermic, so the reverse reaction is endothermic. It will be the same magnitude, but one will be a negative energy change, exothermic. The reverse will be a positive energy change, endothermic. And finally, a reversible reaction happens in apparatus which stops the escape of reactants and products. Equilibrium is reached when the forward and reverse reactions happen at exactly the same rate. And that takes us to the end of the question.